3, 2, 1.
The broadcast is now starting. All attendees are in listen-only mode.
Good afternoon, good morning, or good evening, depending on where you are in the world, and welcome to today's DevOps.com webinar, Top 10 Practices of Highly Successful DevOps Incident Management Teams, sponsored by VictorOps. I'm Charlene O'Hanlon, and I'm the moderator for today's event, and it's going to be a good one. Before we get into the presentation, though, I do have a few housekeeping items I would like to go over. First of all, today's webinar is being recorded and will be available on DevOps.com about 24 hours after the event. So if you miss any or all of today's webinar, feel free to log on to DevOps.com and check it out on demand. We're also going to have a few polling questions during today's event, so please hopefully we can get everybody to participate with the polling questions. And then we're also going to be setting aside a few minutes of time near the end of the webinar to go over questions from the audience. So if at any time during today's presentation you have a question for our panelists, please feel free to use the control panel and put your question in, and we'll get to as many questions as we can near the end of the webinar. Okay, without further ado, I would like to introduce today's panelist. We can go ahead and switch the slide now. Matthew Boeckman, how are you today?
I'm great. How are you, Charlene?
I'm doing great. Matthew Boeckman is a developer advocate with VictorOps, and you can see, I will let you introduce yourself, but thank you so much for joining me today on the webinar.
Thank you, and thank you for providing a great forum for DevOps topics to be discussed and shared. I think it's great work that you guys are doing at DevOps.com. Like Charlene said, my name is Matthew Boeckman. I'm a developer advocate here at VictorOps. I've spent about 18 years managing infrastructure and engineering teams, pretty much all of that 18 years being on call and focused on software development, particularly in support of e-commerce and transactional systems. So for most of my career, I've been managing systems where uptime is absolutely critical. A lot of that time has been with startups, and I like to say that I was doing DevOps before we actually had a word for it. I just called it being nice to developers as a system administrator. A quick tease for everybody, we've got an ebook that I've authored that's going to be available to everyone who's joined the webinar today for free. That's the DevOps Guide to Incident Management. And a lot of the topics that we're going to discuss on the webinar today are explored in a lot more detail in that ebook. So watch for that coming in the next couple of weeks. So I want to do a quick word about VictorOps. VictorOps, if you're not familiar with us, is an on-call incident management platform. You could think of VictorOps as an event management system that ingests alerts and incidents from any of your upstream monitoring systems or analytic systems. It takes those incidents and then routes them to the appropriate person using pre-configured rules for schedules, escalations, and teams, while also providing some ability to dynamically transform those alerts or incidents, providing contextual information for responders, like links to runbooks, graphics to particularly relevant metrics, or things like that. And it provides a sort of a platform to manage incidents throughout their life cycle. Which is a great segue to sort of the way that we like to think about incident management lifecycle here at VictorOps. And this is good context for everyone on the webinar today of how we're going to sort of go through these top 10 practices that we see the most effective incident management teams having adopted. So for us, the 5 phases of incident management are detection, response, remediation, analysis, and readiness. The detection phase is really sort of what it sounds like. This is where we're making observations, we're monitoring, we're looking at metrics, and we're establishing thresholds. That leads us to the second phase, which is response. Once a threshold has been passed, we need to notify someone about it. Sometimes that someone is actually an automated system response, but overwhelmingly it's a human who has to do some basic triage and diagnosis, acknowledge the alert, perhaps escalate as necessary. The third phase then is remediation. This is where we actually fix things or at least alleviate the symptoms of whatever may be disturbing our baseline system. We talked about fixes and tickets and deployments and things in that phase. For many people, when you talk about incident management or on-call, you really sort of focus on those first three phases, which is fine. That's really where the firefight happens and most of the excitement occurs. But we really think that's to the detriment of teams being successful if you don't also have a significant focus on the last two phases, which are analysis and readiness. Analysis is always sort of an after-action activity where we're going to try and understand what happened. Why did it happen? We're going to try to learn from these systems. We're going to conduct a post-mortem. And the last phase is, in almost all practices, sort of an afterthought, and we call that readiness. That's what we're going to do with the learnings from the first four phases. How can we improve the systems, the teams, and the processes to make our incident management practice much more effective? You can map those 5 phases to a pretty standard incident management workflow and quickly see where each phase sort of nests in. On the left side here, we have the monitored systems. These are the things that we care about. Then we have our monitoring systems that are watching those monitored systems. Monitoring systems lead those alerts out to an incident management platform like VictorOps, which routes to a responder, who then uses a great deal of information to establish context, triage, diagnose, and remediate the problem on the monitored system. Those same responders and those teams then use those contextual pieces of information as well as data gathered during the incident in the analysis phase, which sets us up to be effective in readiness and actioning changes that are necessary to make our environments more resilient or our teams more effective. So as we go through the talk today, each of our tips are going to nest into one of these different phases of the incident management lifecycle. I want to take a moment and focus on the core metric that virtually all incident management teams are focused on, and that's the time to repair. I really like this 5 phases approach of thinking about things because it enables us to focus on how we spend our time in our incident management practice. Time to repair is a huge metric because for every moment that a system is down, our businesses are negatively impacted, our users are negatively impacted, and that's important. But for teams who are trying to get out of sort of a break-fix cycle and get off the proverbial treadmill and make things better, every moment you spend in time to repair is a moment you're not spending analyzing a fact pattern or preparing for the next event. And so shrinking time to repair is significant from a business standpoint because it makes our systems more resilient and reduces downtime. But moreover, for the incident management team itself, it grows your available time to focus on analysis and readiness. And that's really where we see teams get the most bang for their buck, is being able to focus on those last 2 phases of the incident management lifecycle. I've been a little bit misleading in our title today. There's actually 11 top practices of highly successful DevOps incident management teams. And the 0 practice that weaves through everything we're going to say today is iteration. There is no single easy answer to getting better at incident management. The best teams have dedicated some percentage of their overall workflow to incident management practice, whether that be team, cross-training, managing response, honing our detection efforts, changing the way our infrastructure works to make systems more resilient. Everything that we're going to talk about today is realized through iteration and through deliberate time spent in your regular everyday workflow getting better. So I'm going to talk about iteration a lot today, but this is the one that weaves through all of our top 10 tips. So with that said, let's sort of dive into the first phase, which is detection. And again, this is where we're going to observe systems' relative health. The first practice that we see these very effective teams adopting is they have a very blended approach to detection. And what that means is I think at low levels of maturity or as teams are just starting out, they have very basic static systems in place to gauge system health against a metric or a particular threshold. But really effective teams are doing that in addition to synthetic testing. They're using time series data to aid their response and remediation efforts. They've got a heavy practice around application performance monitoring, and they're using log analytic systems to, again, make those teams more effective when they're responding to incidents or analyzing one. So let's look at each one of these. Synthetic testing really is a scripted interaction that validates some critical path in your application. In a transactional system, that might be a landing page determining whether a user is already logged in or needs to register, and then actually scripting these like an automated test as a recurring thing that occurs against your production environments, and alerting an incident management team when these synthetic tests are failing. We can gather lots of interesting metrics about database response time, network throughput, CPU load, that really are important for engineers. But at the end of the day, if a user can't add something to a cart, the system is not functioning as expected. And so great teams are really utilizing synthetic testing to continually get validation that critical paths in their applications are performing as expected. Similarly, time series data, as differentiated from static monitoring, can be a step function in the way that teams are able to evolve their incident management practice. Systems are not static today, so why should we treat measurements as if they were? I think a great example of this is illustrated here in this graph, where we've got two different depictions of essentially the same data point, which is the number of MySQL threads connected to a particular service. The top graph is a time series data that shows the rate of change over a particular time period. And the lower one is just a simple count. Now you can quickly understand that with time series data, we get a much more nuanced view into what's happening in our system, as opposed to it just static, this number used to be 1 and now it's 5, somebody panic. I mentioned application performance monitoring. This is a significant thing that teams can focus on in an iterative way and grow to make their incident management teams more successful. By APM, we essentially mean that we're focused on the complex application behavior that exists within our complex systems today. We're doing thread profiling. We're monitoring third-party calls and seeing if those are successful. We're looking at page performance. This is really getting into the internals of the application, as well as all of the other sort of operational considerations to understand whether or not our applications are healthy. The last one that I mentioned here in blended approaches is log analytics. And there's a lot of different tools that you can use to gather logs into a single, central, searchable, and indexable place. In whichever one you do, it's most important that you do it. Teams that are still sort of gathering logs by copying them from servers, or are somehow or other hamstrung by their ability to access logs and event data, really are spending a lot of time finding the information they need instead of going to a single place and searching and reporting on that information. Similarly, once you are able to gather those logs to a single location, you can start to use that information as a detection mechanism itself to get ahead of events before they really trigger perhaps other more static monitoring methods. The second thing that we see really effective teams really focus on in this detection phase, is that they're focused on the business outcomes. And I differentiate this from any of the purely sort of application or system kind of monitoring you could do. This is where we're looking at what's important to the business and mapping those to our IT workflows. Those same data points become detectable conditions for actionable alerting just as much as a system-specific metric may be. Some examples of that are the key performance indicators in the business. What does revenue look like today versus same day last week versus year over year? Are user registrations down? Are our emails being delivered? How's our channel activity look? Is there a spike of negative comments about us on social media? Now, many of these things callers may sort of dispute are going to be directly actionable by engineers, and that's a discussion to have within your team, whether these become things that directly go to an incident management team of engineers or to other places in the business. But the most successful teams are ingesting this kind of data to provide engineering with a clear picture of the entire ecosystem that they operate in, and not just a purely systems-focused view of incident management. That brings us to sort of our first poll here. And I'm curious, just for the folks on the call, which of these different areas do you feel are sort of most in need of focus in your teams? Is it synthetic monitoring? Is it the statistical techniques? Is it APM? Is it log analytics? Or do you have problems just with basic monitoring today?
Okay, we'll give the audience about 30 seconds or so to go ahead and get your answers in. Also want to remind you guys that if you have a question for Matthew at any time during the presentation, please feel free to put that question in the control panel, and we'll get to as many as we can before the end of the webinar. Okay, we're going to go ahead and close the poll here now, and we'll share the results. There you go, Matthew. What do you think of these? It looks like log analytics and basic monitoring are the big winners here, if you could call them that. What is this what you're seeing?
You know, I don't know that it necessarily syncs with what I see, but it certainly isn't much of a surprise. You know, log analysis is something I think everybody recognizes has a great deal of value, but candidly is hard. As you start walking down every little system in an environment and realizing all of the data you have to ingest, all of those systems that I had on that slide, you know, candidly are hard to operate, and particularly as the volume of data that you're ingesting grows, they either get expensive to operate or they take a lot of operational time. So that's not particularly surprising. And, you know, again, it's honestly not much of a surprise that basic monitoring is a problem. I think in a lot of teams, there's been a way that we've done monitoring for a really long time, and teams or individuals are potentially reluctant to change that. Even in spite of probably pretty compelling evidence that it does need some focus. So that's great. That gives us all some stuff that we can focus our iterations on to get better. Cool.
Great. I think your screen should be coming back up.
Maybe.
Maybe, maybe not. Let's see if we can get it on the dashboard here. See if I can get it back over to you. Sorry for the technical difficulties here, folks. Bear with me just a little bit here. Just a second. And, well, you are the presenter. I'm not sure why it's not showing up again.
How about I'll try and reshare my screen real briefly.
Okay, yeah, why don't you try that?
Better? There we go.
There we go.
All right.
Thanks.
No worries. Okay, so let's talk about the second phase of the incident management lifecycle, which was response. And this was really notifying someone, starting to dig in, thinking about escalations and things like that. So the third tip that I have for the folks on the webinar today is to keep your alerts actionable. And if you've had a focus on DevOps incident management, this is not news to you. Unactionable alerts create a confusion, a sandstorm of noise that teams have to wade through to really understand what is meaningful and what isn't. And it can be deeply overwhelming. Where teams are not focused on actionable alerts, we see a great deal of burnout. In the research that VictorOps has conducted through the State of On-Call report, we see that alert fatigue is one of, if not the leading cause of burnout. And alert fatigue can certainly be entirely because of actionable things. In environments that are really falling apart, people are going to get burned out about that. But the thing that really seems to rub people the wrong way is when they're getting interrupted or woken up in the middle of the night for things that they can't do anything about. I like to think about actionability on two primary dimensions. The first is fairly obvious. The alert itself has to be actionable, and that's differentiated from something that's merely informational. You know, a queue size that's growing that isn't actually indicating system health problems somewhere else isn't something a person should get alerted to. You should really only be sending alerts that are interruptive to your team when an immediate action is required. The second dimension is that the alert itself has to route to someone who has the access, permission, and skills necessary to actually perform the action. You don't want this group of jokers probably responding to your alerts. And you know, the humorous image aside, I think that there's some really standard examples of unactionable alert routing that teams struggle with. A classic one is when an ops person is woken up because the load on a system is high, but the offending process is the application itself, and all they can do is escalate to the applications team. Why were they involved in the first place? And similarly, I think a common complaint from developers is that they may get lots of alerts, but they don't have the access to systems in production to actually do anything about them, so they just have to turn around and alert the ops team. Keeping alerts actionable and focused to people who have the access and ability to manage them is key to being successful in incident management. A side part of that is the alert fidelity itself. You have to ensure through iteration that you're measuring the right thing at the proper precision. You'll never get this right the first time you have a new alert, but through analyzing your alert process and what you're detecting and alerting on, you can get much better at alert fidelity over time. Our fourth focus area here in response is really that chat ops is an area of focus in these teams. If you're not familiar with the concept, chat ops is really just providing a central collaboration channel for incident management teams and likely for your developer teams, your application teams, your DevOps teams, everybody. Examples of that might be Slack or HipChat or Matters Most. And at very low levels of sort of chat ops adoption, we basically see this. There's the chat channels that everybody uses to fight fires. And this is a step function above the alternative where you have lots of asynchronous conversations going on. When you provide teams a central collaboration channel, it gives them, first of all, just an easy place to know to go to discuss a topic. But as we'll see in the analysis phase later, it gives us a wonderful time series sort of play-by-play of incident management actions. As teams really start to adopt chat ops more, they start integrating them with their workflow systems, their telemetry and monitoring systems. So in Slack, I might be able to view the status of a ticket. I might get deployment information getting dropped into a HipChat channel. I might be able to pull up a Grafana graph or search for a particular piece of information in Splunk from within chat. And that further enhances this idea of sort of single place of collaboration, as well as single place to understand what actions were performed in a firefight. At very high levels of maturity, teams have taken chat ops to the logical conclusion, and they're using the same chat platform to manage their infrastructure. They're kicking off deploys from within a channel. They're restarting services, restarting servers. They're spinning up development environments. And at this level of chat ops adoption, in a post-mortem sense, a team can go through and see every action that occurred, both informational and actual actions, and it gives them just that a fantastic view into what happened, when, by whom, and what the effects were. But in all cases, during the response phase, it's giving us a single point of entry for all of the activity that we're doing to manage our incidents, and that's just again a step function above lots of asynchronous scattered attempts to manage those same incidents. So that gets us to our second poll today, and that's just a question: how much are you chat opsing? I'll say that chat opsing is a trademark term. You can't use that. That's mine. But you know, are you doing no chat ops at all? Do you have a little bit? Have you done some light systems integration, or are you fully integrated where chat ops is controlling your infrastructure?
All right, great. We're getting a lot of people answering this polling question, so we'll give you guys about 10 or 15 seconds longer, and then we'll go ahead and share the results. But if you got a question for Matthew, as I've reminded you before, go ahead and get your questions in using the control panel. Also, we are going to be tweeting out the results of these polling questions after the event, so if you miss any of the poll results and you want to take a look, then please just check your Twitter feed. Okay, we're going to go ahead and close the poll now. And here are the results. There we go. Wow,
Yep.
Basic team and individual chat. That's kind of interesting. I would have thought that more people would be, you know, on the Slack channel or something like that.
You know, this actually completely syncs with my expectations. That about half of people are doing something. 25% of people still probably using, you know, I've been in teams where there are 3 or 4 different chat platforms in play, and if you wanted to talk to the app team, you use this one, and if you want to talk to ops, you use something else. It's hard. It's genuinely hard because there are cultural elements here too to encourage teams to use a single platform. And then to the point of the last two options, light systems integration or full systems control, you know, this represents probably a year or more of work to get to that kind of integration. And again, I strongly advocate to focus your iterations in this way because of the benefits that it can bring to your incident management practice. So that's great. All right, let me see if I can get back.
Just share your screen again.
Okay. There we go. All right. So our third phase is remediation. This is really fixing things. So the fifth tip I have for everyone today is that runbooks are central to the remediation efforts. And when I say central, I contrast that with lots of times a team or an individual responder may have a sort of haphazard approach to solving the problem. Runbooks set a team up for consistency and really reducing that time spent in TTR by providing responders with all of the context they need to manage these systems. So let's talk about great runbooks. Great runbooks provide clear explanations of system metrics and alert thresholds. And I think this is something that really gets teeth when we talk about technically complex environments. Microservices, as one example, are a really great architectural choice for a team to make, but also come with a great deal of technical complexity. And the idea that in a complex environment that everyone in an on-call rotation will know everything about the environment, candidly is absurd. And so a runbook has to provide a responder with clarity on what's being monitored, why, and what those things mean. Great runbooks similarly clearly identify dependencies, both up and downstream. What might occur north of this system that could cause it to behave badly? And if the system's in a poor state, what are the things south of it that are going to be affected by it? If the runbook can't do that, at the very least, it has to clearly identify a subject matter expert. I like the idea of a little, in case of tragedy, break glass and call Kyle or Bob or Sue, whoever the person is that knows the most about this application. That makes it much easier to get to quick remediation for whoever is responding to the incident. Great runbooks have some automated way to leverage other workflow systems and track incident history and list known failure conditions. Does this alert go off every Tuesday at noon? Is this the first time we've ever seen this? Providing context to the responder helps them more quickly triage, diagnose, and remediate the incident. I think that the last two things are perhaps unspoken, but really do speak to challenges that a lot of organizations have. Great runbooks have to be accessible to all. Far too often there's a documentation system owned by the ops team and a different one owned by the network team and some other one owned by the application team. And some of us have accounts in one but not all the rest, or we're rarely use somebody else's system and so we don't know how they've organized the data. You have to be in a place that everyone on your team is using runbooks in a similar and consistent way. And then very much to my point of iteration, you're never done maintaining your runbooks. This has to be something you're carving off time for regularly to improve them. My sixth tip is really tough, and this is configuration and infrastructure as code. When you get to solving problems, fixing difficulties, having disparate ways to manage application and infrastructure is a liability for your incident management teams. So however you want to define infrastructure as code or configuration as code, whether you're using configuration management systems like Puppet or Chef, using cloud systems or container systems, the basic idea that your dev and ops workflows are very similar, if not the same, can be a step function in how quickly your teams can remediate errors. In an ideal state, the most effective teams have adopted a common path. A commit to a Git repository kicks off a build or a deployment, which kicks off automated testing, and then we go through a simple deployment chain or pipeline to get that change through our testing environments and out to production. This gives us the ability to instrument everything about our common pipeline and really is a level up in remediation efforts for teams. And I don't want to sound disingenuous. I recognize that if you're not in a place where you're doing infrastructure as code, getting here represents potentially years of effort. So to my point around iteration, this is something that is worth focusing on. You can't get there tomorrow. But when you arrive, you'll find that you're in a really magical place in the way that incidents are auditably and efficiently remediated. So let's talk about our fourth phase, and this is analysis. Analysis, again, is all of our after-action understanding of the fact pattern and trying to understand what occurred. My seventh tip is that the data drives those investigatory processes. And I really want to contrast data-driven investigation with subjective-driven investigation. The best teams have adopted something very akin to the scientific method. They make an objective observation, They think of questions and formulate hypotheses. They test those hypotheses, and they're mindful of the data they have to gather within that hypothesis to validate or to iterate on the hypothesis. And things are conducted in a very rigorous fashion. In a very similar vein, teams in this analysis phase that are excellent are also thinking about the people and how cognitive bias may cloud our judgment as we try to understand fact patterns. This, by the way, is confirmation bias, if you're not familiar with it. These teams in their analysis phase are really asking each other, is this a valid conclusion, or do we have some selection criteria that's affecting our output? And they're able to talk with each other about those things. At extremely high levels of proficiency, those teams have realized that there is no root cause. And this is going to get a little perhaps metaphysical, but when you think about systems that are complex, there is emergent behavior that you can never truly predict or expect or understand. And I think a lot of us have grown up in root cause analysis-led postmortems that really keep a team thinking about a system as a static entity, that if there's any variance, that means something has occurred that caused that variance. And if we can just ensure that never occurs again, then things will never go wrong again. And that just isn't true. Complex systems have emergent behavior. There are almost always multiple causal factors to lead to an undesired event. Whether those are system or team or process related, the best teams in analysis phase are really focused on understanding all of the causal elements to an undesired condition, and then they're trying to get better about that over time. So I'm dying to ask this question for our third poll. When you guys and gals on the call think about your postmortem or your after-action work, how are you actually getting to the source of truth? Is it objective, discipline, and verifiable? Is it a bit of a mix of that and maybe some intuitive thinking or deference to senior team members? Or is it just a confusion of tribal knowledge and crystal balls and herbology?
I like that last one a lot. All right, and we've got a lot of folks voting on this one, another popular one. So we'll give you guys a couple more seconds before we close out the polling. We've gotten some really great questions in from you guys also to put out during the question and answer period with Matthew, but there's still time. If you've got a question for him, please feel free to go ahead and put it in, and hopefully we'll be able to get to it near the end of the hour. Okay, we're going to go ahead and close the poll now, and here are the results. Healthy mix of objectivity and intuitive thinking wins the day.
That's
great.
That. The standard that I've set out here is, again, to be candid, pretty high bar. We are ultimately human beings, and oftentimes pattern matching and subjective thinking is good enough. We don't necessarily have to spend the amount of time necessary to be rigorous about why the volume filled up. The logs were growing, and we need to truncate the logs. So I think that that's a reasonable place for a lot of people to be. But I think the more you can focus your iterations, your analysis efforts towards objective thinking and hypothesis formulation, the better you'll be to really understand and learn from these complex systems and behavior. Awesome. So let's see if we can get back. All right, there we go. So my next tip in the analysis phase, that again, if you focused on incident management, you've heard this before, we have to keep our postmortems blameless. I imagine everyone on the call has been present, if not been the sort of subject of finger pointing and blame in an after action. Well, if you hadn't done that, the next thing wouldn't have happened and we wouldn't be having this conversation. There is absolutely nothing to be said in favor of blameful postmortems. They create, very negative trends within your culture, particularly against junior team members or people who are trying. I think that teams who are afraid of receiving blame or being blamed for their actions are less likely to take productive action and are far more likely to hoard information. So the best postmortems really focus on learning. To my earlier point, they focus on data. They require objectivity in the conversation. You get to say in the context of postmortem, I don't think that that's supported by the data, so let's table it. And the last one that really isn't related to blame or blamelessness is that the best postmortems encourage participation. I would wager that everyone on the call is going to go to a meeting later today where someone in the meeting is not engaged. The best way to really learn the fullness of the fact pattern is to ensure that everybody in the team is engaged. And one of the best ways to encourage that participation is to, through our culture and through how we conduct the postmortem, make people confident that they're not going to be called out or blamed for saying what's on their mind. Sometimes this starts to sound a little bit like a hippie drum circle, and I'm not really advocating that level of maybe sort of absurdity, but I think encouraging teams to share in a free and open manner is the best way to really arrive at the clear understanding of what happened. And again, this is where I think ChatOps adoption can really help drive it, because we don't get into a scenario where people are remembering things differently from something that happened 2 or 3 days ago. We're able to just look in our Slack channel or our HipChat channel or whatever and understand exactly what happened in a very objective and clean manner. All right, home stretch. So we're at our 5th phase here, which is readiness. And remember, readiness is the culmination of all of the previous phases, and what are we going to do about it? How can we set our teams, our systems, our process up for success in the future? My 9th tip here is that the postmortems populate backlogs. Now, whether you're a Kanban shop or Agile, however you manage your workflow, I think that the teams that are most successful ensure that actionable things come out of a postmortem. And I contrast that with, honestly, a lot of us, myself included, who have a day-to-day job that gets interrupted by incidents. We all scramble to solve the problem, and then we maybe talk about it afterwards, and then our day job crowds in, and we never get back to sort of solving or doing things that could prevent that condition in the future. And so ensuring that what comes out of that postmortem enters your regular work stream is, at least in my opinion, one of the things that those successful teams are all doing to ensure that those conclusions from postmortems get actioned. You think of a standard workflow, it may look something like this. We call the postmortem, we overview the incident, we review the timeline, the remediation, and the response efforts. We discuss the improvements, and that's the end of the flow chart. Now we're back to our regular day because we were behind thanks to this incident. The best teams have this additional step, which is adding to the backlog, and I think particularly involving the product or project managers so that they understand how to weigh the postmortem incidents or the postmortem backlog work against other things that are in those same work streams, like improvements to features or systems. The last tip for everybody today is that the most successful teams in analysis are focused on team response. So we can say a lot about how we detect incidents, how we respond to them, what we can do in our infrastructure to make it more resilient. But if you aren't also focused on the way the team itself operated, again in a blameless way, but in an objective sort of analysis of what we can do to make our teams more successful, you're kind of missing the boat. You know, what this tip really underlies is that the people doing this are people. We're humans. In stressful situations, often in the middle of the night, being assaulted by information and new data points in lots of different from lots of different quarters, and setting those teams up to be most focused and most efficient really is a step function in your incident management practice. Some examples of that are there formal escalation policies in place, including a catch-all escalation. I think that between that and a formal communication plan with the outside business, these speak to a basic truth. You don't want the first responder unsure of who they should contact. You don't want them pulling up a call down list and just starting to manually dial for help. These should be system actions. Ideally, they're automated so that when things go south, that the engineers are able to focus on solving the problem or alleviating the symptoms, while the rest of customers or business concerns are being notified in automated or simple ways. There's a sidecar to this, which is that as teams sort of swarm to solve problems, we have a few sort of formal roles that get introduced. The first one is an incident commander role. I like to think of this as a quarterback. This is a person, probably senior on the team, who's going to direct and deduplicate team efforts. They're going to have some of the team focused on proximal cause and some of the team focused on alleviating symptoms. And really, this is also a person who can call the ball on action. I think frequently an engineer may have an idea of how they can solve the problem, but it's risky. We've never tried this before. I'm not sure what's going to happen. Someone has to be present in the event to say yes, no, or maybe to those sorts of questions. A similar, or I should say a related role is the incident commander or scribe. This is someone who's really just offloading all of those manual communication steps from the engineering team himself and enabling the engineers to focus on solving the problem while someone else is focused on internal and external communication. So those are our tips, and I want to close today by bringing us back to this graphic of our time to repair. Again, the more time you spend remediating incidents, the less time you really have to focus on those last two phases that are how your team can really get off the treadmill of fighting fires into a much happier place of managing incidents in a productive way. By shrinking that time to repair, you grow the opportunity for your team to focus on time to learn, and that's these last two phases. I think that is maybe the last part that I'll call back to. The postmortems have to populate backlogs. If you are successful at shrinking time to repair, but you don't focus on these last two phases, you'll quickly find that time is just eaten up with new feature requests and new meetings that aren't really moving your incident management practice forward. So as you are successful in reducing time to repair, make sure to create space for your team to focus on learning and understanding these deeply complex systems and the emerging behavior that they exhibit. That's everything I have for us today. I hope you've enjoyed the talk. Again, my name is Matthew Boeckman. I'm at Matthew Boeckman on Twitter. The slides and the presentation will be on DevOps.com, and they'll be up on my SlideShare. And please keep your eye out for the free copy of the DevOps Guide to Incident Management, which is hitting the shelf in the next week or so, I think. So with that, I'd love to see if we've got any questions.
Yeah, we've gotten some great questions, and there's still time. If you do have a question for Matthew, please feel free to put it on into the control panel there, and we'll get to it. First question here is from Shannon, who asks, from ChatOps, do you recommend this getting to a tracking or ticket system where incident is recorded?
Yeah, absolutely. I think much has been talked about around the sort of the cognitive switching cost of teams having to go between multiple tools. So if I understand the question correctly, I think a really impactful thing you can do with your ChatOps is integrate it with your ticketing system. So I'm declaring an emergency. In the chat window, I say Jira space, create space, incident, and then the subject line. And now that incident is created in a ticketing system, and I'm back to whatever troubleshooting I'm doing without having to flip in and out of those different systems. I think that can be really impactful for teams, and usually, depending on what you're using, it's pretty low effort, high reward. Most of the modern ChatOps platforms have, out of the box integrations with most of the, the more common ticket and incident management systems like ServiceNow or Rally or Jira or what have you.
Okay, great. I have a question here from Harry, who's asking, troubleshooting application performance varies from app to app. So is there any best practice that can be started with the DevOps team or shared? I'm not sure.
Yeah, that's a tough question, and what makes it tough is sort of exactly what the attendee has sort of pointed out is if I have a PHP app and a Java app and a Ruby app and a Go app, the metrics for each one of those are going to be different, and the ways that those systems are behaving are going to be different. And so I think if I have any advice, it would be to start with what are the common points that all of these applications are going to behave with, and start there in our APM practice, and then iterate. Make sure you're carving out time. I think the best teams are spending maybe 5 or as much as 10% of their roadmap on the incident management elements of their practice, not just the development efforts. So if you get to some common place to begin, that at least gives you a jumping off point to then customize each of those different application stacks or those different APM stacks against your different applications.
All right, that sounds like a great place to start, actually. Okay, we've got a question here from Ashok, and you may hate me for asking this question, but the question is, how do you prepare and plan for the unplanned?
I think I'll give a glib answer and say you don't, but then I'll give a much more intelligent answer and say it speaks very much to the things that I talked about in my readiness phases. You don't know what is going to happen. That's fine. But if you know that something bad could happen, spoilers, it will, you do know that things are going to have to occur. Someone's going to have to notify the business. Someone's going to have to notify the CFO. Someone's going to have to tell sales not to run a demo. We're going to have to make sure that everyone on the team is reachable. We're going to have to ensure that of the subset of reachable people, one of them can be sort of the leader of this swarm. And so if you focus on the sort of process elements of how the team responds, that at least takes a little bit of the pressure off the team who's also trying to figure out what the heck's going on with the system. US East is burning. What are we going to do about it? Don't also worry about how you're going to notify biz dev about the problem. So I think you can sort of prepare a team or at least set them up to be able to focus on the problem by ensuring that all of the ancillary actions around incident management are nailed. There's no question of who they call or who they escalate to. And iteration is sort of the other part of that is after you experience that unknowable thing, man, update your run books, make sure your detection is in line to get that condition next time, and sort of apply that learning back to all of the different phases of incident management that we talked about.
Okay, well, you did a great answer for a difficult question. I'm very impressed with that.
But that question speaks to very much the heart of all of this is, I've been doing this for nearly 20 years, and almost weekly I see new things. There is no perfectly predictable state in complex systems, and we have to do everything we can to just be ready for all of the kooky and exciting things that are going to happen to us today.
That goes along with the, hope for the best, but prepare for the worst.
That's right.
That same type of mentality there.
And this, I'll get back to this just briefly, but this sort of speaks to the there is no root cause thinking. Once you accept that systems are dynamic elements and that the emergent behavior of these complex systems that we're building for ourselves are going to be unexpected conditions, a lot of times we talk about just managing expectations within teams is important. And if everybody comes to the table with an expectation that things are occasionally going to catch fire and go south, we're less surprised when that happens. And just as people, I think you respond better to it if it's sort of an expected outcome as opposed to a surprise.
Makes total sense, yeah. Okay, all right, great. So we're at about 12 minutes to the top of the hour, so we have time for a few more questions. Miriam asks if you could clarify regarding the runbooks concept. She said, I suppose it is implemented using a knowledge-based tool. Is she right?
Yes, absolutely. I think of any collaborative documentation platform, Wiki, Confluence, etc., is ideal. You want to ensure that everyone can edit the document. You have version history so that as edits are made, ideally in the positive direction, but sometimes maybe incorrect edits are made, that we can understand that and revert and track the version history of these things. Those knowledge bases or documentation systems, to my point earlier, have to be accessible to everybody who's on call or anyone who might be escalated to. Sometimes the responders get access to that knowledge base, but the rest of the team doesn't. And that similarly creates sort of this anti-pattern where we don't all have the same transparent view into the data set that we're using to establish context. So however you get there with runbooks, in the very, very old days, runbooks were 3-ring binders, always red colored, and they'd be on a shelf in the knock. Fortunately, today we can do things a little bit more intelligently. But yeah, some knowledge base or documentation system is ideal.
Okay, great. We have actually another question from Shannon. She says, seems that some of these points have a blend of incident and problem management. So from a DevOps team perspective, do these disciplines begin to come together?
Yeah, and that the question sort of is asked in a way that is, I think properly identifies the way these things get conflated. I like to think of an incident as being sort of any abnormal state of the system. I shouldn't say abnormal, but any unexpected state of the system that we're able to detect, through anyway, and detection certainly can be somebody running down the hall waving their arms, oh my gosh. But that's an incident, and those can be very small, and a collection of incidents can lead to an event. And an event is something that is business impacting. If you want me to build that out a little bit, an incident may be volume utilization growing in a disk subsystem. That's not that big a deal. When it gets full, now all the applications are thread locked, the world's on fire, and everybody's unhappy. That's an event. So yeah, I think that the incident management practice and problem management practice are almost identical in many ways.
Okay, all right, great. Okay, let's see, let's move along. Our next question is from Kim. She's asking, or he's asking, what are some of the biggest challenges you have seen with global DevOps teams, you know, various time zones and cultures, and how did you solve them?
Yeah, so for me, and whether you're talking about global or even just you know, single located geographical teams, particularly when we're firefighting events, you know, something that's going to take a while to solve. Team members sort of join the firefight and leave the firefight. You know, somebody's been up for 30 hours, let's let them go to bed and get somebody else activated. Managing sort of, you know, round the clock or by the sun firefights or incident problems is tough. And this is for me where that scribe role that I talked about earlier is really important. A thing that I see a lot of teams doing now is using a Google Doc that is, and whether it's a Google Docs or a ChatOps channel, but somewhere where we're recording sort of all of the different salient bits of information for the incident, so that as teams rotate out or on, they're able to, you know, sort of put their diary together for what they've done so that other teams don't duplicate that effort. And for new people joining the firefight, they can just go and read the synopsis, and we don't have to take time away from other people fighting the fire to explain what's been tried so far. You know, the idea of the story so far, if we can capture that in a succinct way to enable anybody rotating in and out to get up to speed quickly, that can be a real step function to making those teams successful. I think the other part of that is just chat ops. You know, if we're all hopefully largely fluent in a similar language, you know, I think audio suffers a lot from a quality and fidelity standpoint when we're talking about globally disparate teams. There's really not much that gets lost in translation if we're all in chat ops versus I couldn't hear because the connection was staticky or there was an accent that I'm not familiar with or what have you. So I think those two things can help sort of alleviate those concerns.
Okay, great. I got a question here from Samaya, and I'm going to read it word for word, and hopefully together we can figure out exactly what it is that Samaya is looking for. The question is, what if the team is performing extra tasks like release management, deployment, etc.? So can we create a backlog even if the team is not doing incidents management only?
Yeah, that speaks to the heart of many of the points that I was getting at. I think that it is frequently true, if not almost always true, that the team, however you want to think about it, that's managing incidents, also has a day job. And they might have 3 or 4 other day jobs. They might be application developers who are also responsible for infrastructure and are also writing code for features. You know, that's sort of definitionally what they're doing if you call them DevOps. And it's sort of why I call out the need, the absolute need for postmortems to populate the same work streams that those teams are using for their other day jobs, because this stuff gets crowded out. Teams deal with the fire and then they get back to their day job because they have deliverables. And if we don't track that sort of reality in a common system, then the people managing those alternate work streams aren't really aware of those efforts by the team or the need for those efforts to be given, if not similar status to features and things like that, then at least, you know, very proximal status to those things. So I think you have to expect that your incident responders have other jobs. And if you're going to be successful at incident management and not be in a constant state of break fix, you absolutely have to devote some percentage of expected time to getting better at it. If it, I assure you, everybody is going to spend time making the database better the first time the database crashes and it causes a production outage. That's the wrong approach. Knowing that you need to spend whatever number you want to come up with, 10 hours a week making incident management better, that's the single biggest thing you can do, because it speaks to my first point of iteration to really set those teams up for success. And if you don't do that, I can assure you, you'll never get off the treadmill. You will constantly be fighting fires, and it just won't get better.
Okay. All right. Great. I think we have time for one or two more questions here. Kaio is asking, correct me if I'm wrong. I love questions that start like that. Correct me if I'm wrong. But since infrastructure is code, we should keep everything in version control. Only things like explanations, business objectives, etc., should be documented in a wiki Confluence. Is that correct?
So I won't correct you entirely, but I'll certainly distinguish a little bit of what the questioner is getting at there. So in infrastructure as code, absolutely, everything is stored in a version control system. And as an operator, then I can very quickly and easily see, the rate of change or the last known change of anything within that particular system. And that's well and good. But I still think you have to have an external source of truth about the systems and the way they operate, because what you can't have is a first responder logging on at 3 a.m. to deal with an incident and reading the 8,000 line long git commit history for this service. You will never get to context. Well, you will get to context by reading 8,000 lines of commit history, and it will take you several hours, and your business will not exist by the time the rest of the team wakes up. So having those infrastructure as code comments are super helpful to get a team to know immediately what changed. What were the last 3 deployments about? But then having a broader sort of context setting runbook, I think is the quick way for somebody just to say, okay, what is this thing? I got an alert about server 5827-LL93. What is that? Is that an NTP server, or is it a database? So having, I think, a blend of both is important.
Okay. All right. Great. 2 quick questions here. Amit is asking, do you have any tool suggestions to store historical incidents?
Yeah, so I think that it's kind of an interesting question, because depending on the environment, the answer is going to vary massively. My super short version is use VictorOps or use an incident management platform. If you accept my tip earlier about multiple detection methods, you're going to have, automated test systems doing synthetic testing. You're going to have log analytics systems reporting on new conditions. You have all these different systems, each with their own sort of idea of what an incident is. And by having those flow to a common platform, again, like VictorOps, you then within VictorOps have a history of all incidents associated with any of the different alerting platforms involved in our environment. If you don't like that answer, the corollary answer is, if you're using any kind of workflow management system like ServiceNow or Jira or whatever, and you're disciplined about every incident has a ticket associated with it, you can get to that similar fact pattern of all incidents associated with a service or a team or what have you. But however you get there, the questioner is right in that that's important. And there's probably some discussion you could have about how long you actually have to maintain that incident history. What happened to a platform that's 3 years old 3 years ago probably isn't super relevant in establishing context today, but gosh, the last 3 months, the last 6 months of that incident history might be particularly helpful and meaningful for incident responders dealing with the problem in the now.
All right, great. Well, I think that's pretty much all the time that we have for questions. I'd like to thank everybody for submitting some really great questions. And if we didn't get to your question, just know that Matthew will be getting a copy of all of the questions, and I'm sure he'll be more than happy to follow up with you guys offline. But please check devops.com for future webinars that we have going on. And then also, as I said before, this presentation is also going to be on the devops.com website, probably about 24 hours following this event. And then also Matthew said that he will have his slides on devops.com and slideshare.com. So Matthew, thank you so much for taking the time and giving us such a great presentation today. I know I got a lot out of it, and I'm sure the audience did as well.
Great. I hope so. And Charlene, again, thank you for your help in moderating this and just in general to DevOps.com for providing such a great platform for people to discuss and share ideas and approaches around DevOps. It's great. So thank you, everyone. And thank you everybody who joined.
Thank you, everybody. Thanks for joining us, and we'll see you next time. I'm Charlene O'Hanlon, signing off.